So here's the problem. Here's our two knowns, and we got to change the temperature to Kelvin because you can't do gas law problems in degrees C or in Fahrenheit. You have to have Kelvin temperature. So we're going to add 273.15 to this. $298.15, but this last digit over here comes from an empty slot, so we have to underline the last digit and round that off, and we get 298.2 K, and that's going to be our temperature. All right, and the question, oh well, we'll hopefully it'll be all right. Okay. All right, so let's see. It says we want to find density. We don't know density. Okay? Well, what kind of equations do I have on my test references? Did it freeze on me there? Oh, man. Okay, that calculate density.
Right.
Wow, how about that? Well, let's see. I need pressure. I've got pressure. I need temperature. I've got temperature. I need molar weight.
Got molar weight.
Well, I have the species up here.
Right, you gotta calculate it, baby. Let's go. Let's be quiet. You're overboard.
Okay, now these numbers come from the periodic table. Okay. And the reason we're multiplying the mass, the atomic mass of oxygen by 2 is because there are two
carbon dioxide.
Two oxygens in carbon dioxide. That's CO2. Di means 2. Okay. All right. So let's see. 15.9994 times 2, and then we're going to add 31.9988, and we're going to add to that the 12.0107. And you get 44.0095, and that's grams of CO2 equal 1 mole of CO2 in the format we've used in this class. However, for gas laws, we need to write that as a fraction. Now, we always use it as a fraction. We always built our conversion unit based on what we needed in the equation up to now. But for gas laws, we're going to start with it as a fraction. So the molar weight or molar mass of CO2, CO2 here, I'll put CO2 down here just to make sure we're clear, is going to be 44.0095 grams CO2 over 1 mole. Okay? That's what we're going to do, molar weight. Well, we've almost got everything we need. All right? The other thing that we need for this ideal gas law, or version of the ideal gas law, is R. We need to choose R, and that's on the front page of your test references, based on what knowns and what values or units of measurement we already have. So we have atmospheres, we have atmosphere's pressure, we have Kelvin temperature, atmospheres, Kelvin temperature. We don't really need to worry about the other stuff right now. We got, well, let's see, liters. Do we have liters? No. We just have, that's not in our equation. Density is, let's write it down over here and see what we need. Density is the molar weight or molar mass times pressure times R times T. Okay? So we've got molar weight. Pressure is atmospheres. Temperature is Kelvin. And so all we need is to make sure that the R unit matches the pressure and temperature. Okay? Got it? All right. So then our R value is going to be, and most of the time if you match the pressure unit, you're going to have the one you need. It's the pressure is the key one. Okay? So we need 0.08206 liters times atmosphere over Kelvin times moles. And now we're ready to put all these things into this equation. So we've got temperature here, we've got pressure here, we've got R here, and we've got the molar weight over here. Okay? We're ready to put all that in. Alright, so density then is going to equal molar weight, 44.0095 grams per mole. I don't really need the species for this because the species doesn't change. Okay, I could put species in there, it won't hurt anything to do that. Alright, and then we're going to multiply that times the pressure. The pressure is 1 atmosphere. And then all that goes over this big fraction. We have a complex fraction we finish. 0.08206 liters times atmospheres over Kelvin times moles. And then we're going to have temperature, which is 298.2 K. 298.2 K. Alright, so we've got this big complex fraction. And we need to rearrange the fraction to be able to solve the problem. So what I want to do is what I was taught to call invert multiply. Okay? Got it? All right, ours is not the reason why, only to invert multiply. You ever heard that before?
Nope.
You haven't? It's a paraphrasing or sort of a twist on a famous phrase from a famous story. Okay? The Charge of the Light Brigade. Yeah, it's the famous line from the Charge of the Light Brigade, if I remember correctly, is ours is not the reason why, only to do or die. Little literary reference there. Hmm? Okay.
Okay, gotcha.
All right. So what I'm going to do is invert and multiply. I'm going to invert what's on the bottom. So I'm going to put Kelvin moles on the top of this fraction. And I'm going to put the 0.08206 liters atmospheres on the bottom. Yes, ma'am.
Do we have to like spread it all out, or can we just do the complex fraction?
Are you saying should you just do all this? And well, how do you know what to cancel by doing that?
Because if you have the same variable, like whatever.
Yeah, but let's don't go with usual. Let's be sure. Okay? And I would rather you do it all the way out and show me exactly where the canceling of units comes in. Okay? Because I've seen a lot. I mean, you may be able to do that without doing it, but some students think they can and really can't. So let's not take shortcuts right now. Okay? All right. So let's see what cancels. Moles cancel.
Mole.
Atmospheres cancel.
Yeah.
Kelvin units cancel.
Yeah.
And I'm left with grams per liter. Wow, what do you think grams per liter measures?
That's density.
Density of a gas. Those are the units we use for density of a gas.
How about that?
How about that?
I know.
So we know that because we have grams per liter, we have a density measurement. We're measuring mass per unit volume. Okay? All right, so we just plug in all our numbers here. 44.0095 times 1. Well, I don't have to multiply by 1, do I? Because it gives you the same number, does it? Well, you can do it by 1 if you want to, but it's going to give you the same number. So divided by 0.08206, I'm going to hit enter, and then I'm going to divide by this number as a separate function or separate operation, 298.2. Well, I don't really have to divide by 1 because it's going to give me the same number. Okay? So, well, that's fine. You can do that. It's perfectly okay if you do that. I'm not going to, that's never going to be a problem if you do that. Okay? Because it's better to do the extra operation to be sure than to not do something you need to do. All right. Excuse me. 8486916. And I get to look through this whole problem, this multiplication division problem, and see how many significant digits I need in my final answer. I need to match the significant digits in the measured or calculated number with the least digits. And so this is measured or calculated. This is measured. This is a calculated number. That's a measured number. So this is the one with the least digits, 4 digits. 1, 2, 3 significant digits. Underline everything that follows that. And I get, let's see, that's going to make that a 10, which makes this an 8. So that's 1.80 grams per liter. and that's the density of CO2. I'll put CO2 up here, but I could just emphasize that by saying density CO2. But this is at 1 atmosphere and 25.0 degrees C. Okay? The density varies based on temperature, especially for gases. So when you're giving me the density of a gas, you need to specify what pressure and temperature. Okay? That's really important. All right? I mean, I wouldn't count it off against you at this point, but it does become really, really important at some points. All right? Any questions? Okay. So this solving gas law problems, there is some interpretation. Okay, not a lot, not like in the previous units. Okay, there's not a lot of interpretation of the problem here. You write down what you know, write down what it's asking for, and simply find the equation that fits the variables you have and don't have. Okay, and plug it in. The only thing you have to remember here is that while you're not given the molar weight of carbon dioxide, we've been doing that for what, a month? You can calculate the molar mass of carbon dioxide, right? Yep. All right, and also R. You have to figure. You have to know you always have R. Yes.
Do you have to write the molar mass fraction, like with the pressure and the temperature and all that, like at the top?
Say that again. The molar mass.
Yeah, like the fraction. Do you need to write that down, or can you just?
No, molar mass won't change based on pressure or temperature.
No, I mean like you have to. Is that one of those required things that you have to write it in the fraction?
Oh, do I have to write it as a fraction? The math doesn't work out if you don't. So for gas laws, see, up to now, we've been using only this way of doing molar mass. All you had to do is figure out the equality statement. And then we built the fraction we needed, right?
I mean, I understand about the mathematics. You have to write it on paper so you can see it.
Yeah. I need to know what you did, how you got it. Right. Okay? Always better to write it down than not write it down. Okay? Then you're sure. Okay? Because if my grading form says they show me the molar mass in a fraction, you got that point, right? So you're sure, because that's the way I teach it. Okay, if I teach it that way, that's the way I want you to do it. All right. Now later on in a college class somewhere, AP chemistry, you might not, the teacher might not expect you to do that, but because you've gotten so used to doing it, you're less likely to forget that's what it was. Okay, and that's what I'm trying to emphasize is. That's what it means, and that you have that in your head, right, Charlie?